All right. So today I'm going to talk about a bunch of security issues I found in my time in Traceable. So I'm a security researcher at Traceable, which is an API security company. I got my start in security a long, long time ago, back when I was really young and I wanted to play Pokemon games and Xbox games. I was always having fun with Action Replay and Game Shark, which are like cheat devices you would use to unlock special things in games. So many years later, I decided to try my hand in like web and API security because there's only so much you can do with the game console. So I thought I would try and shift my focus to like websites to see if the knowledge I gained with hacking game consoles could be applied to like real world websites. So I ended up being very successful in like a few years ago. So the first major breakthrough I found was a security issue with a hot tub, a jacuzzi hot tub specifically, and that was the first time I really made major headline news. So that was really humbling to get that out there. And then I decided to try my hand in like automotive security next because one day it came to mind. We have a Toyota, so I wonder if there's anything I can do with it. So Toyota was one of the first automakers I decided to look at the websites of, and I ended up finding a very severe vulnerability where I could basically take over their supplier portal, and that also made headline news. And after that happened, I got a bunch of companies that were interested in my work, and Traceable was one of them. So ever since all this stuff happens, it really helps me get my foot in the door in the security industry. So it was really humbling that my independent research was so successful and highly impactful. So today I have a particular focus on like high impact vulnerabilities, not small things. It's just like the big ones where you can like take over accounts and big corporate data breaches. And I also like to continue my work in automotive research, of course. So when I try and find a vulnerability, I typically look for an issue with authentication and authorization because if they mess up there, that that's usually a critical flaw, and it can basically take over the entire app. And this happens more than you think. Every app usually needs some form of auth, and usually people get it wrong a lot of the time. And when you get this wrong, you basically expose the entire app to data leaks. And if it's like a bank, you can steal other people's money and stuff like that. So if you mess this up, you're really in for a tough time. And single page apps are a key thing that people screw up on all the time. And I'm going to show you why. So a single page application is something, it's a framework called Angular, React, Vue, etc. These are all really popular web frameworks used in the web dev community. And they're very easy to reverse engineer because the entire bundle gets downloaded to your browser. And unlike server-side apps where you don't see the entire app at one time, when it's a single page app, you see the entire thing. So you can look in the source code of the app and find like API keys and even usernames and passwords as seen on the right here. And these are two real world examples. The top one is an example of an Amazon Web Services key that exposed access to a bucket. And then the password here and user ID below, it basically gave access to a Tableau instance where you can log in and view all the financial details about a company. So these are highly impactful vulnerabilities. And this is all because people leak their keys in the source code because no one would think that people would just right click view source. But it really is that easy sometimes. And the thing is, when you leave a code comment, you might think at the end, this gets compiled out, right? But it turns out a lot of people like to deploy their source maps, which is like a debugging symbol of sorts. So this stuff does not get stripped out, and it's left for people like me to find. And that gives me that makes things a lot of fun when you get have these types of things to look at. So this is a brand new vulnerability that I just found last week. in a very large consulting firm that's in the process of being fixed. So in the comments of the component did mount function, which is a standard Angular function used in the SDK, they left some testing administrative tokens for the Microsoft Azure login. So if you take any of these and put them in the local storage with the name adel.id token and then refresh the page, you would have full admin access to the app. And all these tokens are actually used in the underlying APIs. So these will be put in the authorization header, and when that's sent to the server, it would accept it, and you would have full admin access to all the resources on the API, basically. So this is in 2025, so this is still happening every single day. And you, as developers, you really need to be careful what you put in your apps. If you leave a comment, make sure it's not a token or a password. So I'm going to dive into a few real world vulnerabilities of very high impact that I found over the past year or two. And this is a brand new one I just disclosed last month in December. It impacted McDonald's India. If there's anyone from India in the audience, then you might have used the Indian Make Delivery service. It's basically like number 15 in the Apple App Store as of a few days ago. So it's definitely one of the world's most popular food apps. But it turns out they had some supersized vulnerabilities and critical flaws. And it was a lot of fun to find and disclose these problems. So let's dig into it. So the first thing I looked for when I was analyzing the app was to look for any type of URL, or it's also called a route, and see if there's any interesting pages I can try and exploit. And the first one I found was an order tracking page. If I looked at the underlying code, it needed an order ID, a user ID, and card ID, but all that really mattered was the order ID. So all I had to do was put the URL in the browser and change the placeholder value to an integer value. I just tried one as a quick test. And as you can see, it actually returned valid data. And all you had to do was increment that number by one and up to like 200 million. And you could get all the orders. And these are all API requests in the background that show the user ID, that the information, phone number, stuff like that. So it was very serious. So the next one is a bit more interesting. There was a way to basically order any number of menu items for only 1 rupee for $1, 1 US penny, I'm sorry. So how it worked was you would add any number of items to your carts. So one thing I did was I explained in my blog just in a theoretical sense. So I had my yacht off the coast of Mumbai, and I wanted to treat the crew and myself to a nice dinner. So I ordered 100 hash browns and just a special drink for me because who doesn't like hash browns? Every time I go to McDonald's, I love the hash browns. I wish they would serve them every day, but you have to go at the breakfast time, unfortunately. So I set up my accounts. I put in my address, which is just I came up with like a 1337 number because that's the best number to use. So from there, with the carts set up, I tried a few methods to get the price down to basically $1 or like $0. I tried a few things, but it turns out it was actually mostly secure. So when you submit the order to the payment processor, there is a signature that covers all the important data like the price, the user ID, and such. So if you modify that string of data as it gets sent to the payment processor, it'll reject it and just give you an error message. So I had to go back to the drawing board at that point. And what I came up with, so the orders API works by you put the items into your cart, and this is done by put requests. And at the end, when you want to submit the order and get the string to submit to the payment processor, you tell the orders API to give you back the signature object in the string. But before that happens, I wanted to try to actually change the price. So I did a put request using the gross price of just 1.0, and it actually changed the order price to just one. And it actually worked. I was able to check out using this modified order. And as you can see from there's receipts here, it ended up being just $1 total. So this is actually real. I submitted the order, but then I canceled it afterwards so that no one would actually make 100 hash browns and send them off the coast. So the next one I want to try was it possible to actually steal someone's orders that they were making, like an order that was being paid for right now. And this was a tricky one to figure out because you had to figure out what order was being paid for at like right at this moment in time. So I came up with a way to, if you submit an empty payment request to the payment API, it will return an empty placeholder object with the latest order ID in the system, and that would be yours. So if you subtract one from that ID, you would get the last order ID that was created, and that would actually be a valid one. So if that order ID indicated it was still being paid for, all I had to do was do another put request to change the address ID to my own. And after that, the user would not know that the order was just stolen behind their back. And so they pay for it. And after they paid for it, they would basically see that the address is wrong. So, and another thing you do was do another put request to change the user ID right after they pay. So it would get reassigned to your account. And then you would have, or the customer would not see the order at all. You would have taken over the order completely from them, from their accounts. So they would have paid for the order, and then they would not see it. If they called customer service, they'd probably be like, "We don't see your order. You didn't pay. Go away." So this is definitely a very devious and sneaky thing to do. But it was very difficult because precise timing is required. You had to know exactly when someone was about to pay. But it did work. And it was a very fun exploit to show to the McDonald's team. Those are only a few of the very high impact vulnerabilities I found with McDonald's India. There's more on my blog and also more on this YouTube video that just came out a few days ago. It was made by another security researcher named Low Level TV. He's a very popular security researcher on YouTube. So feel free to copy that link or scan that QR code to watch later. It's a very amusing video. It goes over the entire process step by step, and I really highly recommend you check it out if you have a couple minutes to spare. So the next one is one of my CVEs that came out at the end of 2023. If you notice the trends here, some of my big exploits seem to come out right at the end of the year. The McDonald's India one happened in December of 2024, and this happened a year before that in 2023. So I had to wonder what's going to happen in December 2025. I'll probably end up finding another big security problem. Let's see what happens. So in this case, this is a very severe vulnerability I reported to a company named Ally Digital. They created an IT as a system service that basically means that it's like an all-in-one help desk, CMDB, IT ticket help system. So it's something you would integrate into your organization to help with IT support and stuff like that. It was built in Angular, which is basically the same framework that McDonald's India used. So this is just another case of Angular having being developed in a way that makes it vulnerable. It had a login screen, but it turns out when you logged in, it didn't use the token and the API request that followed. So you log in using your valid username and password, you get the token back, but they didn't do anything with it. And that was a big flaw because after you log in, you really need to make sure the APIs that follow use this token. But in this case, you didn't need to. All the APIs run unauthenticated. So all you had to do was just request. But but first I'll show you how to actually bypass the login page. So the way you got to find a way to bypass login pages, typically I look into the source code and figure out how the login works. In this case, it's controlled by a local storage object called obj login data. If that exists and the valid fields are there, it'll just it'll think you're already logged in and let you continue in the app. But since I don't have a valid username and password, I had to figure out a way to construct this token without any valid user data because I was just not in the blind. So if you search for the obj login data field and the entire JavaScript source, you can find all the fields like the user ID, first name, last name, stuff like that. And with that, you basically reconstruct the JavaScript, the JSON token, and then you can put into the local storage. So on the right, this is what I came up with. The user ID of one, this is just a random value. I just thought, but I did not know the user ID format. It could have been like a GUID or just an integer value like one. So I just want to try the number one to see if that would go anywhere. It turns out this is actually the important part, and I'll show you why shortly. So with that put in place in the local storage and the page refreshed, the app would load. And the reason this worked because so if you look closely at this request, that user ID of one, like in local storage, is used in all the API requests and the query parameter. Notice how there's no authorization header here or anything else. There's a few tokens like cross-site scripting and other cookies, but these ended up not being important or anything. All that mattered was the user ID at the top. And it turns out the user ID of one was the global system admin. So when you did this get resolved incident list, it will return all of the data from the targeted organization. So in this case, it will return like all the IT trouble tickets and stuff like that. And that's made worse by the fact that since these are IT tickets, they had like usernames and passwords to the responses and other sensitive details. So it was pretty bad. And if you work with APIs a lot, you'll know how a megabyte of data is a lot to work with. And this is several megabytes, so there's a lot of data being breached. So that was only one company. It turns out there's about a little more than a dozen companies that use this software. I found about 13 of them, but I suspected there were probably a lot more. I basically had to do a creative Google and Bing search to find the companies that use them. There were airlines, real estate, even mining companies that use this. And this exploit applied to all of them. So without anyone knowing, you can log in, dump all the data, and be on your way. And there's a lot more than just IT tickets. Like you could hook it to your organization's email for to keep audit logs for like compliance purposes and such. And as a system admin, you could see all the emails that people were sending and receiving, and even all the devices people were using and all the details. Like if you work for a big company, they'll have like a catalog of the devices on the network, and this had the complete map. So it was really just you, you could use all this information to get further into 13 plus of the world's longest orgs. And this is all fixed, and there is no data breach or anything. It didn't really make widespread news because I wasn't allowed to name any of the affected companies, but it was a pretty big deal, and I'm glad it got solved before there was any big data breach. And I still think this is one of the biggest API data breaches I've ever came across because one system opened up 13 of the world's large orgs to complete data breach. And with the passwords you can find inside, you can get into various other systems. So definitely just a massive impact. So during the disclosure process, the company tried to fix this a variety of ways, but I I did find easy ways around each of the security measures they implemented. So one of the first things they tried was since my example I sent to them was using the dev tools to manipulate the local storage, they thought it'd be clever to basically add a check for if you have the dev tools open. And if you did, it would redirect you to a different page, so it would stop you from manipulating the local storage value. But all you had to do was basically modify the JavaScript to increase the timeout from like a second to like 500 seconds. And then it wouldn't interfere with your work and the exploit will work. The second thing they tried was local storage value encryption. What that means is before it would load and store values in the local storage, it would encrypt and decrypt them. And the way they thought that helps is since my exploit worked by putting plain text values in local storage. If they implemented encryption, well, I would be stuck. I wouldn't know how to do it. But there is a very easy way around that. So when you implement the encryption, this is all client side since there's local storage. So all you have to do is find the code they did to do the encryption decryption, set a breakpoint, and then you can see exactly what they're setting and you could just call it a local storage set item, which would use the encryption key and all that to set the values to local storage. That would do the encryption, and the exploit would work because it's properly encrypted, and it would be properly decrypted later as well. So do not do any of these. Assume anyone can open the DevTools. You cannot stop them, so don't even try. Please do not use client-side encryption. It's kind of pointless. And if you do, that that just tells me you're probably hiding something, and I'll find a way to beat it. And there's probably a vulnerability there that you're trying to hide. So please don't do that. So when you're building authentication and login screens, please make sure you use the token. So when you set the login and get the token and the response, make sure you send it along with like the get IT tickets and other user update requests. Don't Make sure the server also validates it because there's many cases where I noticed that the API will have the token in the request, but the server won't check it. So make sure you have at least a simple test to make sure that the token gets sent and it gets validated on the server side. But they're very important. So going into some of my automaker hacks, this is a semi-new one I found in a very large heavy truck manufacturer. If you have a semi-modern car, you'd open your phone app to figure out where you might have parked in the parking lot because like it would have a real-time tracking system. And the same thing goes for these heavy truck manufacturers, but this is more like an enterprise system for internal use only. And it would basically have like an overview of almost 60,000 trucks and where they're located across the entire world. I don't think it was for consumer use because it was basically behind the corporate login, but it's just like the previous vulnerability. This login screen was not effective, and I have an image depicting its its effectiveness. You could easily get around it. So here is how this bypass worked. But first, I had to find how I worked, just like the last one. So when I see a login page, the first thing I do is just like right click view source. And I'll usually see the scripts at the bottom of the page. At the top here, these are just third-party scripts and other style sheets that aren't really that interesting. But towards the bottom are the scripts that the company actually developed. And these are the ones that you want to keep an eye on. So like rest.url.service app.js. These are the high profile scripts you want to take a look at. So it turns out the app.js had the clues to that allow me to bypass the login screen. And here's how it works. It basically checked if the URL address bar had an access token by the query parameter. And if it did, it would actually proceed with the login process. But it turns out you could put any login token there at the top. It didn't have to be valid. And if it's not valid, the get user info request you can see here would actually fail. But this is actually it was an optional request, so it didn't matter if it failed. All that mattered if there was a token of any value, it would proceed through the login as if it was a valid token. And if you look at the bottom here, you can see this is an example of the bypass. You just had to put a single letter as the token, and it'll let you into the system. And this is what it ended up showing. The dashboard basically showed an overview of the entire worldwide truck network. You can see there's almost 60,000 trucks that are just waiting to be tracked, and how many are having trouble. The term D2C is like diagnostic trouble code. So these are cars that they're trucks that are broken down or and need some help. And this is presumably what this system was designed to help with. So this is a showcase of the actual live tracking system. You can see how it predominantly affected trucks in Japan, but also Australia and South Africa, none in the US. So this is primarily an overseas exploit, but that doesn't really lessen the impact at all. So if you zoom into the map, you can see in real time how fast the trucks are going, if they have any problems. Like the one at the bottom here, I noticed was broken down into 7-Eleven. So they're probably just waiting for a tow truck. And this is all real time, so this was happening as I was looking. So that was pretty cool to see. And that's all fun and games, but what about like the real nefarious impact of this exploit? This is all theoretical, but I believe it would have actually been this would have been a potential attack vector. So imagine that a guy wants to rob one of these trucks. Since he knows where they all are, this would make it substantially easier. But the trick is to know like what trucks are valuable to hijack. So I came up with a theory. Like, what if someone tracked a truck to a jewelry distributor and they just loaded up on like precious gems, gold bars, stuff like that? And then they thought the hacker follows the truck in this web app and waits until they stop somewhere like a rest stop. At that point, the bad guy would just go and like rob the truck. Since the robber knows it was just at the jewelry store, there's there's a high chance there's some valuable goods inside. And this applied to a number of other scenarios besides jewelry, like maybe steel or other valuable things. So there are a lot of possibilities that this could have opened for criminals. This is just one I came up with. So you might wonder, like, what was the problem here? Why did this API show me all this data? So after the login bypass, I just had Fiddler, which is basically an HTTP proxy. It showed me all the API requests that the web app executed. And there was mainly one critical API that returned all the data about the trucks. So whenever you changed like a filter or a page on the website, it would call the API to get an update. It turns out this had all the record of all the trucks, like the VIN number, the latitude and longitude, and this would all just get plugged into the real-time map. And it's just like the last vulnerability, there is no authorization header here. So you could actually just open this vehicle uptime summary URL in Google Chrome or any other browsers, and it would show you all the data in plain text without any login. The map was just a nice way to present it, but you could have easily plugged this into another app you wanted to develop. For example, like if you wanted to monitor latitude and longitude, if a truck was getting close to a high value store or something, the possibilities were definitely endless with this one. So moving on from the automakers, I'm sure everyone knows Honeywell. They had an app called the Basic Engineering Design Questionnaire, which is like a web app designed for the oil and gas industry to submit pipeline projects and other projects in that industry. It's used by like the world's largest oil and gas orgs like Shell, BP, and just many, many others. This is another very obscure internal web app, and it had a series of critical flaws that basically allowed me to get super admin access to it. And it started with just one vulnerable API, the user's API. All I had to do was look into JavaScript code again to find these APIs. I typically like to look for the user's API or like a login API to see how these things work. So in this case, I found the user's API, and I basically did a GET request to the root of it, and it would return all the users registered in the system. So that in itself is already a huge flaw because I just had access to who all the people registered on the site and their email, their last name, first name, stuff like that. So I wanted to go a bit deeper to see if there's any way to kind of actually get into the app and start it instead of stealing some user data. So the way Honeywell works is anyone can register an account. They have like a company-wide SSO system that even consumers can register with. If you try to access like an internal system, it'll usually kick you out. But with the login token being valid, there's still like an opportunity where you could get into a system, analyze it, and try and find a flaw. And that really helped in this case. So when I logged into this bad queue system, it would come back with an error message saying you are not authorized. Not very surprising. So I came up with an idea because since the users API listed all the users in the system, I thought, what if my Honeywell account was added to this bad queue system? And then I logged in. Would actually let me in after I did that. So I couldn't find a way to actually add a new user with my email address. So instead, I just I found a test user and decided to do a pull request to update their details with my own. So I changed the test user's email to my own, but I also set the internal and super admin flags to true just to see if I could actually full access to the system. And if you look in the response here, you can see how it accepted it. I was in theory the super admin of the BedQ system, and the only way to find out was to log in. And after I did that, it's it worked. I had full access to all the private engineering projects of all the major oil and gas titans of the entire world. And there's many pages across various countries like Bangalore, Egypt, Korea, Canada, the list goes on and on. And this all had some very private information, like just about the various projects they're making, pipelines, stuff like that. It's not something you really want out there for the world to see. This is all reported to Honeywell, and they fix it in pretty short order. So everything I showed you was all very obscure internal web apps. They're not typically indexed by Google. So how do you find them? A few years ago I discovered that certificate transparency logs are really a way to just find all these internal web apps, and it basically supercharges my vulnerability research because literally in seconds you can come up with a domain, plug it into a certificate transparency log, and download thousands of domains for a particular site. A certificate transparency log, if you know what an SSL certificate is, it's basically a ledger of all the certificates being registered and purchased in the world. This is done for transparency, hence the name, so that the authorities have some sort of accountability in case there's abuse of the certification process. But the downside for them is this catalogs all the internal websites and URLs that are being protected. This works best on big targets like Mercedes-Benz, Toyota, and other older companies. So like in the case of Mercedes-Benz, you have almost 5,000 domains. Just go through those one by one, find something that's like an Angular or React app, and so you can quite quickly find some vulnerabilities there if you're lucky. So that's just a small sample of all the work I do. There's a lot more if you want to follow Traceable's Aspen Labs and also follow me on LinkedIn. I have a lot more in store for the next few months, and I hope you'll consider following me because there's some really high impact research in progress right now, and I think you're really gonna love it. Hope you enjoyed that. Please let me know if you have any questions or comments. I'd be happy to answer them.